Good morning, UP scientists. Today we're going to continue talking about how plants make food. And to start off with that, we're going to be looking at a game. So, as ecologists, we've been working to figure out why the cecropia trees aren't growing and thriving. So in order to figure out the answer to this question, we have been investigating where the food molecules for those plants come from. So if you look back at yesterday's assignment, based on the ideas from the book and the sim, what new understanding did we come to yesterday about where plants get their food molecules? All right, so your new understanding should have been something like plants make their own food molecules by using water molecules, carbon dioxide molecules, and the energy from sunlight. And one place we saw that was on this page here. We had the leaves were taking in carbon dioxide, had the roots in the soil taking up water, and the leaves were collecting energy from sunlight. So what do we think that plants use their food molecules for? So today, we're going to be showing you a game called Leaves and Roots, and it'll help us explore where plants get their food molecules and what they use them for, since it's hard to observe these things directly. So this game is going to serve as a model of how plants get their food molecules and how those food molecules become molecules that help build the plant's bodies. So unfortunately, we can't all be in the same place to play the game together today. So, but last night I played a round with Miss Speck so we can see how the game works. So goal of the game is to add body matter to your plant until it has 5 roots and 5 leaves. So you collect sunlight, carbon dioxide, and water to make food molecules, which you trade in for leaves or roots. So here's a quick video that tells you the instructions on how to play and what the rules are. So let's share that.
Let's explore how to set up and play the Leaves and Roots game. We'll get into groups of 4 and then divide into teams of 2. The 2 teams will play against each other. Each team will have 1 game board and a sheet with directions. Each group of 4 will share 5 cups of game pieces and 1 set of game cards. Each pair should take the following items from the cups and place them on their game board. 2 green pipe cleaner pieces for leaves, 2 brown pipe cleaner pieces for roots, 1 yellow token for sunlight, 1 blue cube for water, 1 white cube for carbon dioxide. On each turn, your team will take 1 carbon dioxide and 1 sunlight for each leaf you have. This represents how plants take in carbon dioxide and sunlight from the environment. Next, turn over a card, read it out loud, and follow the instructions. Root disease. Lose 1 root. Decide whether to add a leaf or a root to your plant to make it grow. You can only add 1 leaf or 1 root per turn. Look at the game board to see if you have enough to trade. If you choose not to make your plant grow, your turn is over. To add a root to your plant, exchange 1 food molecule using 1 sunlight token, 1 water cube, and 1 carbon dioxide cube. Or, to add a leaf to your plant, exchange 2 food molecules using 2 sunlight tokens, 2 water cubes, and 2 carbon dioxide cubes. Let's choose to add a root. We'll add it to the plant on the game board. Now, it's the other team's turn. The first pair to grow 5 roots and 5 leaves on their plant wins.
All right, so let's take a look and see how that game works. Mr. Beck here, and I'm joined by Miss Beck, and we are going to play a game of leaves and roots.
So excited.
So excited. I'm going to make the most leaves and the most roots.
Yeah, watch me.
All right, so my turn. I'm going first because it's my class. And so I'm going to take, I have 2 leaves, so I'm taking 2 carbon dioxide and 2 sunlight. Okay, and then we flip over a card to see what happens. There's water underground. If I have roots, I collect 1 water. So I'm going to do that. Now I have another water. Great. Now I get to make either a root or a leaf. So I'm going to use 2 of my food molecules. So that's carbon dioxide, water, and sunlight. And I get to make 1 leaf. All right.
It's very impressive, Mr. Beck.
It's my turn.
All right, so I am also going to take, for each leaf, so I have 2 leaves, so I'm going to take 2 carbon dioxide, 2 carbon dioxide, and I'm going to take 2 sunlight. All right, let's see what my card says. Morning showers. If you have roots, collect 1 water. I do have roots, so I am going to collect 1 water. Oh, sorry, water is blue. That's how that works.
Okay.
And I am also going to create a leaf. So
you're going to
1
grow.
Food molecule and 2 food molecules. And that is my leaf. Wheel. I hope none of my leaves die in the process.
Ooh, they might. Horrible things might happen to
What
plants.
if the rain doesn't come?
We'll see. We'll see. All right. So now I have 3 leaves. So I'm going to take 3 of these guys. And
I'm going to take 3 of these guys. And 3 carbon dioxide and 3 sunlights. And then we see what happens. Competition. Oh no. Take something from the other team that plants need to grow. 1 water, 1 carbon dioxide, and 1 sunlight.
Take it from me? That's not fair.
That's competition.
Oh,
It's
man.
competition. I'm gonna take your sunlight.
Wow.
Gonna block out your sun, and now you're in the shade.
I'm not sure if I like the way this science is going.
Alright, well,
Alright,
unfortunately, I have no water, so I cannot grow.
Oh, this is true. This is true. Okay, so now I also have 3 leaves, so I'm going to take 3 carbon dioxides and 3 sunlights, although I also don't have water, so I also can't grow.
Oh, see what your card does.
Let's see what my card does. Springtime!
Oh no.
Take 2 water, 2 carbon dioxide, and 2 sunlights.
Wow.
Oh, it is a great day for being me. 2 waters, 2 more carbon dioxides.
Wow, you have
I
all
am
of it.
rolling in the molecules. All right, so I think I will make another leaf because I can.
Mhm.
And I need leaves. There they are.
Alright.
Look out, Beck.
Alright, more carbon dioxide. I have too much of it. And more sunlight. It is so shiny in here.
It's very bright.
Okay, let's see what happens. A flood. Teams who have roots can collect 2 waters.
Ooh, that means I get to collect them too.
Yes, you do. Well, you can. You don't have to.
I'm going to.
It says you can.
Yeah,
Are you
well,
sure you
I
want
will,
to?
yep.
Okay, fine. Okay, so I am going to build a root. So I have my 1 food molecule and turn it into a root. There we go.
So you're at 3 and 3.
Mhm.
We need to get to 5 and 5, right?
Mhm.
I'm at 4 and 2. All right, let's see what happens. I get 4 of these. So I have all the leaves. And I get 4 of these. Let's hope there's not some horrible drought.
Is it a drought?
Fungi!
Oh, fungi.
Fungi grow on the roots, taking twice as much water as you have roots, up to 4.
Whoa.
So that means I get 4 waters.
Yeah.
Ho, 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 ho. All right, so
You and your decomposers.
how many things can I buy? As many as I have
Just 1.
food for? Oh, right, okay. Well, then I will max out my leaves.
Okay.
Max
Plants can
out
only
my
grow so
leaves.
fast.
I'm gonna beat you.
See.
I might need some more roots to sustain these leaves, or they are going to die off.
Probably. Alright, so gonna get some carbon dioxide. Gotta get some sunlight. Competition. Take something from the other team that plants need to grow. I'm gonna take this water. I'm gonna build a leaf with it. 2, 3, and a leaf.
Oh. Catching up to me.
Yep.
Catching up. Alright, so 5 of these. 2, 3, 4, and 5. 5 sunlights. It's a very shiny day, kind of like our hydroponic growing system where we have some leaves sprouting on some lettuce. Hopefully some tomatoes are coming out soon. It's very exciting to watch grow. Okay. Deer eats a leaf, lose a leaf.
Oh no.
Sad. Well,
You're gonna
I'm
regrow
just
it?
gonna grow that leaf right on back. Here it comes back to me, leaf. Come back to me, leaf.
There you go. Alright. Take these, 4 of them for my 4 leaves. And I'm gonna just leave the sunlight because we're gonna run out. Say we have enough sunlight. Okay. Oh no, it's hot, dry weather. I lose 1 water that I don't have any of.
What happens now?
Nothing happens.
Nothing.
I can't grow. I can't grow.
Okay.
My growth is stunted.
Just gonna get some more carbon dioxide. I'll just pretend I have enough of that too. Oh, chance of rain. Take 1 water or 1 sunlight. You may only take water, but you may take water only if you have roots. You may take sunlight only if you have leaves. So I have both of those things, and I'm going to go with water.
You sure? Okay. You have sunlight.
Wait a minute. Because I forgot that you're just messing with my head. Okay. And I am going to make a root. Give me a root.
Okay. Carbon dioxide. Sunlight. From my leaves. What happens? Competition. Give me the water.
Why are you stealing my stuff?
Because I'm a very competitive plant.
Apparently.
Alright, I'm gonna use that.
You're the kind that wraps your roots all around and squeezes the life out of another plant.
Now I'm the big tall plant that looms over you. Alright, I'm gonna make a root.
Yeah, very looming.
Looming plant. Look at this.
Oh, you are getting close.
Alright, here we go.
I need some water. Okay. H2O. Nope. Carbon dioxide. Sunlight. Water underground. If you have roots, collect 1 water. Booyah! Okay. I'm gonna grow another root. I'm 1 root away from outgrowing you, large tree.
Oh no. Alright, let's see what happens. Get our carbon dioxide and our sun from all our many, many leaves. I have a growth spurt. I collect a water, carbon dioxide, and sunlight. And I'm gonna spurt that growth right into my roots. Alright, it's your turn.
Okay. Alright, I need 1 more root. I just really need it. So, okay, carbon dioxide and sunlight. Let's see. Light rain. If you have roots, collect 1 water.
Oh, no.
Oh! Somebody's gonna win! Root! I got roots. What's that song? Oh, it's not a... I'm gonna embarrass us all.
Yes, yes. Alright,
I
and
have
that's it.
1! I have 1 leaves and roots. I am the growingest of all plants.
Alright, so now we're gonna go ahead and talk about that game back in the lesson.
So remember, the Leaves and Roots game is a model. So in that model, what did we need to make our plants grow and thrive? Then when were our plants not able to grow and thrive? And how did we add body matter to our plants? All right, so as you saw in the video, we were able to grow and thrive only when we had all 3. We had carbon dioxide, sunlight, and water. We weren't able to grow and thrive. We weren't able to add any roots when we were missing one of those things. And in our game, usually it was water that was missing. And then we added body matter to our plants. We added roots and leaves by trading in those 3 things, the sunlight, the carbon dioxide, and water, and turning it into body matter. So where do you think the food molecules for plants actually come from? Okay, so to answer that question, here's our next key concept. So I want you to write this down in the box off to the side here, and also write it down in your paper notes so that you can access it when we're making explanations later in the chapter. So plants use water molecules, carbon dioxide molecules from the air, and energy from the sun to make food. And so we learned in our first chapter of this unit that animals grow by changing food matter, which is made of molecules, into body matter, and plants actually grow that way too. So we're going to modify an earlier key concept that we had, which just talked about animals, and now we're going to write it down to include plants. So animals and plants grow by changing food molecules into body molecules that can build their bodies. So write this down in your notes and in the space off to the right. Now, let's think about how the game showed how plants get and use molecules. So how is what we saw in the game different from what real plants do, right? Because remember, models help scientists see things that are difficult to see or help them answer questions about the world. However, they always involve some sort of simplification, so they won't show things exactly perfectly. And some models are going to show some things better than other things. And one thing that you might have noticed in the model that isn't accurate to real life is that at some point my plant ran out of water, and if a plant has no water in real life, usually that plant is going to start losing leaves and eventually die. But in the game, you're just allowed to keep going. So next, we're going to take a look at plants in an ecosystem and build a model for them. So we're going to work with this model of an ecosystem to show our understanding of where plants get their food molecules and how they use those molecules. So we've worked with a similar model before. You'll see some similar figures with some of the organisms over here. All right, so we've seen the zebra. All right, so in the previous one, we saw the zebra, we saw the grass, we saw the cheetahs, and we also had these empty boxes that represent matter moving through an ecosystem. Previously, we just had these 4 food matters as options, and those are still going to go in those 2 tan boxes. But now we also have carbon dioxide and water coming into the plants, and we have these boxes over here to represent the amount of water matter and amount of carbon dioxide matter coming into the plants here and here. All right, so you're going to just drag these over into the arrows that are pointing to the grass. And then remember, you also want to show, if you click on the drop-down menu for the grass, the zebra, the cheetah, you can show how much grass, how many zebras, how many cheetahs there are. And the goal is to show the amount of matter moving through an ecosystem when there are more plants. So to model this, we're going to use the drop-down menu. The first thing you should do is go to the drop-down menu above the grass and change it to more, very healthy. And then you're going to build the rest of your model, dragging matter cards into the empty boxes to match what happens when the grass is very healthy. So you can use the drop-down menus to show how the flow of matter in an ecosystem affects the populations of the other organisms as well. You think there's going to be more zebras, less zebras, a normal amount of zebras, and the same with cheetahs. So to get to this, you're going to go to your 5th grade bookmark. You're going to click Log into Amplify, the bottom button that comes up there, and we'll use our remote learning username and password that are on the screen right now. You want to scroll all the way down and click on the Ecosystem Restoration Unit, and then for today's model, you're going to click on the blue number 3. Once you've done that, you're going to go ahead and complete the model to show the amount of matter moving through the ecosystem when there are more plants. So when you're done with that, we're just going to ask a couple questions about where you put the different cards. So which card did you put in each location? What card did you put between carbon dioxide and grass? What card did you put between water and grass? What card did you put between grass and zebras? And what card did you put between zebras and cheetahs? So these questions should be answered using like the names of the cards that are over there. So if, for example, you put the card that says less food matter between zebras and grass, your answer should be less food matter. If you put the card for no carbon dioxide in between carbon dioxide and grass, you'd say no carbon dioxide for that answer. All right, so questions are coming up right now. Okay, and to wrap this activity up, how do plants use carbon dioxide, water, and energy from sunlight? All right, so if you had the answer to that question, should have been pretty familiar from our key concepts that we wrote down earlier. We're going to finish up today by summarizing things and writing about plants in the rainforest. So now that we've learned about where plants get food molecules, let's think about what we learned. Think about how what we learned applies to the Costa Rican Rainforest Project area. So we want to open up the Google Doc that's attached to today's lessons. So let's take a quick look at the instructions. And remember, as ecologists, we're going to be using scientific language to record our ideas. So you want to refer to those vocabulary words we've been writing down so that you can use them in your writing. So our instructions here are going to be to read the question below. You want to write a paragraph that answers the question. So a paragraph should be at least 3 or 4 sentences. And we want to include what you know about molecules and energy in your explanation. So you definitely want to mention molecules and you want to mention energy. And our question is, where do food molecules for Cecropia trees come from? There's also going to be a spot in the Google Doc for you to make a drawing if that helps you explain your thinking. If you do a drawing, we're just going to do it in Google Docs, and you'll be able to use the insert menu up at the top, click on insert, drawing new, and you can make a drawing there. And if you do make a drawing, make sure you label it so that we know what's going on. So at this point, go ahead and write your explanation about where food molecules for Cecropia trees come from. And once you've done that, you are finished with today's lesson. So go ahead and click the Turn In button on Google Classroom. Make sure that you've completed all the questions in this Edpuzzle and also completed that Google Doc. And once you're done with that, you're done for the day, and I will see everybody on Tuesday. Have a good day.